Okay, more little help on graphing polynomial functions. Okay, polynomial function, degree n, will have at most n real zeros and thus at most n x-intercepts. Okay, we'll come to that. It will have at most n minus 1 turning points. Let's have a look at an x to the fourth. Okay, an x to the fourth can have 4 real zeros. Okay, and 4 x-intercepts. Let's have a quick draw of some random x to the fourth. Okay, so if I put the x-axis through there, can you see 1, 2, 3, 4 answers, solutions, x-intercept, okay? But it could sit above, I mean, it could miss the x-intercept, okay? Right, now the turning point, now look, here's a turning point, where it turns, okay, where it increases to decreases, okay? There, and there, it's like where the minimums and the maximums are. 3, so an x to the fourth has at most 3, okay? A pure x to the fourth, just the pure x to the fourth, like this, actually only has 1 turning point. But again, at most n minus 1. It kind of helps you graph. So let's put everything together. Graph the polynomial function negative 2x fourth plus 3x cubed. Okay, first of all, end behavior. All right, leading term test. It's a negative x to the fourth. Hence, falls to the right and falls to the left. Okay, so it's going to look like that. What happens in between? We don't know. Okay, right, we've got that out of the way. Now, find the zeros, let's factor it. We can pull out a negative x to the cubed. We're left with 2x minus 3. Okay, so we'll have x equals 0 3 times. So x equals 0, multiplicity 3. Okay, that's 3 times. Okay, because an x cubed is 0. So 3 times. And also x equals positive 3 over 2. Okay, just solve them equal to 0. So, and that's just 1 time. So it's going to cross the graph at 3 over 2. And it's going to cross the graph, probably with a kink in it, at x equals 0. Okay, so these are the x-intercepts. Have a look there. Let's put it all together again. Right, okay. Oh, by the way, again, if I look at this, if I just look at it, I can see the y-intercept. Okay, when x is 0, there's nothing at the end there. Okay, y-intercept is going to be 0 as well as, of course, the x-intercept of 0. Okay, if you've got an x-intercept of 0, you're bound to have a y-intercept of 0. Okay, there it is. So, y-intercept of 0. Now you can add in a few additional points, okay? Just pick some points in between the x-intercepts, okay, and plot. Right, so what else do we have? It's degree 4, falls to the left, falls to the right. We've got x-intercepts and y-intercepts. Now remember, I said it has that little kink, so it crosses it at 3 over 2. All right, it has that little kink at 0, again, because of the multiplicities. There they are, okay? So that is what the graph of 2x fourth, negative 2x fourth plus 3x cubed will look like. Okay? Again, domain, negative infinity to positive infinity. Okay? Right. Let's have a look at another one. Okay, here's the general rules. If you want to read through that, I didn't really cover too much of point 3. You can use the x-intercepts and any point in between the two. If you've got an x-intercept of 1 and 3, where it's crossed, well, you can put x equals 2 into the equation, see what happens. Is it going up there? Is it going down there? Okay, you can put some more points in. But there's the box, kind of follow little steps, which is what we're doing naturally. And again, I'll go through that again with another example. Graph this. Well, I tend to look at this straight away. Look, I can see it's got a y-intercept of negative 4. Why not get that out of the way first instead of, doing what this is doing? It's got a y-intercept of negative 4. Now, positive 2x cubed. Okay, so, well, positive x cubed. Here we go. End behavior rises to the right, falls to the left. What happens in between? We don't know. Okay, so when we factor that, this will factor by grouping. Okay, so far we're giving you ones where you can factor them. Again, if I split it down the middle, x squared can be factored out, leaves me with 2x plus 1 from the first two terms, and negative 4 can be factored out of these second two, leaving me with 2x1 again. So 2x plus 1 can factor out, leaving me with the x squared minus 4. That's factored by grouping. That's something from previous classes. When we factor x squared minus 4, it's the difference of squares. Here we go. So I should have zeros, solutions, x-intercepts at negative 1/2. There it is. Negative 2 and positive 2. Okay? All of multiplicity 1. So it will cross the x-axis. Let's put that together. Okay, there was the y-intercept. Again, you can pick some more points, just random points in between. It looks like they've picked a point here at, well, I'll pick negative 1. I would pick positive 1, see where it goes, see what the y answer is when you pick those numbers. Put it all together, and there we have it. Okay, so again, the x-intercepts, the end behavior, the turning points, it's an x cubed, so it's got 1, 2 turning points, and that's you putting everything together. Again, domain negative infinity to positive infinity. There you go.